Hello everyone. I am Mohammad Rashid Azam, pursuing a BTech in Electronics from Electronics Engineering Department, ZSCT, MU, Aligarh. Today, I am here to present before you a project on PLC automation. It holds the topic Automated Speed Control Hybrid Board. The whole training is sponsored by TechUp 2 under the Ministry of Human Resource Development, Government of India, NPIU, the World Bank. Technical support is done by ZMS Technology, Germany. Coming to the term, as the term explains, it is a boat that runs on a propeller that is intended to be free from shocks and jerks in the condition that there are several sources available. It sets a minimum voltage requirement level and switches among different sources on preference basis. So it is automated speed control because its speed can be increased, decreased and can be fixed to a particular value irrespective of the change in power sources. Now coming to the term hybrid. It is because we have used three power sources. First is the PV cell, second is the battery bank, and the last is the combustion engine. All these sources mentioned here are on the priority basis, that is according to the preference of the source for running the propeller. Now, in this whole presentation, I will be dealing with real-world problem description and need for automation, automation concept, programmable logic controller, concept underneath, visualization in HMI SCADA, and further steps for this project. Now, coming to the design problem, since it's a simulation project, we cannot take input data from the real-world sensors. So we have simulated the whole day time, assuming the whole day and light conditions in 50 seconds. Assuming that 0 to 20 seconds is the daytime, when solar cell supports running of the propeller, 21 to 35 the battery support, and lastly fuel is used to run a combustion engine to drive the propeller. In the speed control section, I have managed to control the speed of the board by a slider action. We can move the slider to have our desirable speed that varies over the range from 0 to 1500. It can be fixed to a definite value assuming still water conditions, or it can be made to accelerate itself like in cruise control. Now, in this screen I have shown the functioning of the whole system. Here the industrial Ethernet switch connects the different IP based devices like PLC, HMI and the SCADA system. The PLC cells, the battery and the combustion engine is all connected to the PLC, which is controlling the entire process. The HMI or SCADA in turn visualizes the process on different screens. The PLC controls the changeover of different power supply on the priority basis to the propeller and gives the regular feedback to the control panel. Now, in the next slide I have shown that in order to program the PLC, we have used Siemens TIA software. Here we have selected S7-300 PLC with single phase supply and CPU 314 C2 PNDP, which has multiple communication interface, that is Profinet Profibus interface. We have selected Profinet interface. Now coming to our TIA software, here I would like to show you the PLC tags that I have used. All the tags count to 28. Now I would like to show you my network blocks. This is my main network block that has got 8 networks in total, and besides this I have made 2 function blocks, that is function 1 and function 2. In function 1, as I have said that we cannot take the inputs from the real-world sensors, so I have simulated the daytime in overall 50 seconds. Now for this I have made a function block, that is day-night control. This function block controls the whole of the daytime according to the daylighting conditions, that is 0 to 20 seconds. It keeps the daylight on, that is the PV cells will be working, and after that 21 to 35 we will have our battery support, and after that combustion engine will be started in order to run the propeller that will run on fuel. And the third is the speed control. This speed control block actually controls the speed. Whenever we move the slide, it fixes the speed of our propeller, and it can also be used to accelerate. Okay. Now we download our program to PLC. Now coming to the WinCC, here I have shown 4 sections, that is start screen, section 0, section 1 and section 2. My start screen shows the options to navigate between the different panels, that is operation panel, operator panel and the overview panel. Now I would like to transfer my program to the HMI. Now this is my main screen. Here I have shown whole of my information about my project, and I have incorporated whole of the 4 screens. Now this is my start screen. Here I have shown all of the related information. This is the AMU logo, and I have shown 3 of the buttons that help me navigate among the different panels that I have incorporated within this project. This is the operation, this is the operator panel, this is the overview. Now coming to the overview, this screen gives me the overall power supply description of my project. Here is the daytime running, that is 11. That is, as I have said earlier, that from 0 to 20 I have simulated the daytime, that is sunlight time. So therefore it is till 20 my project is supported by solar panel, and then it switched to battery, that is 21 to 35, and you can see that after 35 seconds it will switch over to combustion engine, and the fuel will be used in order to run the propeller, and the boat will run throughout the day. Now you can see that it has switched to the combustion engine and fuel is being used. Now coming to the operation, that gives the overall view of the boat running. Now this is my operation panel. Boat is running with this nominal speed that I have given, 585. Now coming to the operator panel, here it gives me the whole of the control of my system. This is the start stop button. I can stop my boat whenever I want. This is the speed. Whatever speed I desire, I can switch over to it and get it fixed. Now this is the alarming conditions, and this shows the speed range. If it is in range, green is blinking. If I make it go beyond the range, that is uncontrollable range, then it will alarm me. Now you can see that it is control speed is blinking. It's telling me that you have to control your speed, it's beyond limit. Now direction control can also be simulated. It is a 2D view, I have not simulated it. And now you can see the operation. It has gone faster because I have raised the speed, that is 1342. Before it was 500 something. Further steps for this project can be remote access for the monitoring and control, live model for the boat system. Now this is all about my project. A lot thanks to Almighty Allah for providing me with this opportunity, and my heartfelt thanks goes to Electrical Engineering Department for establishing this laboratory in our college, and ZMS Technology for the technical training and support. Also many thanks to all my batchmates, technical and non-technical staffs for picking this project up to a success. Thank you all for watching this video.